fraction form, that is logarithm of m to the base a minus logarithm of n to the base a. We can prove it by similar way. This is the formula number 2. Similarly, formula number 3 is there. Logarithm of m to the power c to the base a, we can write c logarithm m to the base a, that is the power will be the multiple of the logarithm. How to prove this? Suppose logarithm of m to the base a, if it is p, by definition we can write a to the power p equal to m. Now taking both side power as a c, so m to the power c equal to a to the power p to the power c. By the laws of indices we can write a to the power p into c. Again you apply the definition of the logarithm, that is this pc will be logarithm to the logarithm of m to the power c to the base a. We are taking the base a. So therefore what is p? P for this and c for any number. So c logarithm a base m is equal to logarithm m to the power c to the base a. Proved it is. Similarly, formula number 4, logarithm of m to the base a, we can change the base by this alternating way, that is logarithm of a to logarithm of b to the base a into logarithm of m to the base b. That is, you see the diagonal way, b be adjusted, so resulting logarithm will be logarithm of m to the base a. We will get it. We can change this way. Formula number 5, that is logarithm of 1 with any base, it is always 0. How to prove this? We know a to the power 0 means 1. Now apply the definition. So 0, it is equal to logarithm of 1 to the base a. Very easily we can prove it. Similarly, when the base and number both are same, the value of the logarithm is 1. We can prove it. We know that by the laws of indices, a to the power 1 is equal to a. Again we apply the definition of the logarithm, so that 1, it will be logarithm of a to the base a. Very simple. Formula number 7, a to the power logarithm of m to the base a, that is when the base and the base of the logarithm both are same, the value of the logarithm will be the only the number. Suppose example is there, 2 to the power logarithm 2 base x, it means that only x. Formula number 8, logarithm of a to the base b is equal to 1 by logarithm of b to the base a. If you want to change the base and number, then you have to reciprocal it. Suppose you have logarithm 3 to the 2 base 3. Formula number 9, logarithm of m to the base b, we can write by taking another base, logarithm of m to the base a divided by logarithm of b to the base a. That is, we take another base a or 10 or 5, anything you can take as a base. Suppose you have example, suppose you have logarithm 3 base 2, then you can want to put, if you want to put the base 5, then take 5 divided by logarithm 5 number 2. We can write it this way. Similarly, formula number 10, logarithm of a base m is equal to logarithm of n to the base a, that is we can write m equal to m, provided base will be same. Suppose you have logarithm of x to the base 2, logarithm of 2 to the base 2, base are same, we can comparison this, that x equals to 2 we can write. Moving to the exercise, these are the formula. Now moving to the exercise, problem number 1, it is given, evaluate this. Take it, this is x, let this is x equal to this. Apply the definition. What will be the definition? What is the definition? You see it here. This m will be equal to 4 to the power x. Now 1 by 64 we can write as a index for form 4 to the power minus 3. So that becomes 4 to the power x, and that is x equal to minus 3. So the value of the logarithm is minus 3. Very simple. Formula problem number 3, you see, evaluate logarithm root 6 to the number 216. Take it x. Again apply the definition. This 2 to the power 216, that is equal to root over 6 to the power x. Now 216 we can write 6 cube, and this root 6 means 6 to the power 1 by 2. That means we can write 6 to the power x by 2. Now when the base are same, power will be equal. So x by 2 is equal to what? X by 2 is equal to 3 implies that x is equal to 6. X is equal to 6. Therefore the value of the logarithm is 6. Next number 2a number from your exercise. Let us write by calculating find its base if the logarithm of 625 is 4. Let's move next number 2a number. Let us write by calculating find its base if the logarithm of 625 is 4. That is, we need to find the base of the logarithm. Let base is x. So what is given? Logarithm of 625 is 4. That is, the logarithm of 625 of the base x is equal to 4. By the definition, 625 is equal to x to the power 4. And 625 we can write 5 to the power 4. And there is x to the power 4. That means it is x equal to 5. Therefore, base equal to 5. Similarly, 3a number, you see, this is the relation given 1 plus logarithm of a to the base 10, that is equal to 2 logarithm b to the base 10. Then express a by b, that is we need to find the value of a. This is the relation given. First you know that power law, that the multiple will be the power. So you write log b square to the base 10. Now keep one left hand side and taking this logarithm as the right hand side. So that will be, we know the base are same, so we can apply the quotient law. What is the quotient law? That is the logarithm of base 10, that is equal to b square by a, we can write by quotient law. Now apply the definition, this b square by a, it will be 10 to the power 1. So that is a equals to b square by 10. Understood, no?